Hey everyone, welcome back to the Google DSA series. In today's episode, we will solve a very popular and important question, find triplets with zero sum. This question is frequently asked by Google, Amazon and Microsoft interviews and is a great example of how to combine sorting and two pointers technique efficiently. We are given an array of integers and we need to find there exist any three numbers whose sum is equal to 0. If such triplet exists, we return true, otherwise false. Example 1. 0 minus 1, 2 minus 3, 1. Output true. Because the triplet 0 minus 1, 1 sums to 0. Example 2. 1, 2, 3. Output false. No such triplet exists. Example 3. Minus 5, 3, 2 minus 1, 0, 1. Output 2. Because minus 5, 3, 2 equals to 0. Let's understand how to solve this efficiently. The brute force method would check all combination of three numbers that big O n square time, which is too slow. So let's optimize this using sorting and two pointers approach. Step 1. Sort the array. Step 2. Fix one number, say array I, and then use two pointers left and right to find if the other two numbers make the sum 0. The condition becomes array I, array left, array right equals to 0. If the sum is less than 0, move left forward to increase the sum. If sum is greater than 0, move right backward to decrease the sum. This reduces time complexity to big O n square, much faster and cleaner. First, we store the size of the array n. This makes our loop conditions cleaner later on. We sort the array in ascending order. Sorting lets us use the two pointers approach because we can move pointers based on whether the sum is too small or too large. We fix one number at a time, that's array I. We go till n minus 2 because we need at least two more numbers to form a triplet. We initialize two pointers. Left, start from the element right after I. Right, start from the last element of the array. Together they will search for two numbers that make the sum 0 with array I. We keep moving these pointers until they cross each other. That means we have checked every pair for fixed I. We calculate the current sum of three numbers. One fixed array I and two from the pointers. If the sum is exactly 0, we have found a valid triplet. We can immediately return true because the problem asks whether such a triplet exists, not how many. If the sum is less than 0, it means we need a bigger number to reach 0. Since the array is sorted, we move left pointer forward to increase the sum. If the sum is greater than 0, we need a smaller number to reduce it. So we move the right pointer one step backward. When the while loops end, it means we checked all possible pairs for the fixed I. The outer loop then moves to the next element and repeats. If no triplet was found after checking all elements, we return false. That means no combination of three numbers sums to 0. Time complexity big O n square because we fix one element and run a 2-pointer loop for the remaining 2. Space complexity big O 1 as we are not using any extra space except a few variables. And that's how we solve find triplets with zero sum efficiently using sorting and 2 pointers. This is a great foundation for each problems like 3 sum, closest sum or 4 sum. If you found this helpful, make sure to like, comment and subscribe for episode 16 in our Google DSA series.